Greetings. In this video, we are going to look at linear functions and their graphs. A function whose graph is a straight line is a linear function. I'll just write that down here. A function. And remember, we'll use the notation f of x, although there's nothing special about the letter of f. Sometimes we'll use g of x or h of x, but a function whose graph is a straight line is a linear function. So for example, if I take f of x and say that that equals 2x plus 1. So in a previous video, I talked about strategies for graphing a function using a table of values. So let's just put a few values in here. So 2 times negative 2 would be negative 4. And when I add 1, I would have negative 3. 2 times negative 1 would be negative 2, plus 1 would be negative 1. 2 times 0 is 0 plus 1, that's 1. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. And then let's look at the graph. 1, 2, 3, 4, 5. And that goes on forever. Negative 1, negative 2, negative 3, negative 4, negative 5. And 1, 2, 3, 4, 5. This is my x-axis, my y-axis, and negative 1, negative 2, negative 3, negative 4, negative 5. So I'll plot the first point here, negative 2, negative 3. And the second point is negative 1, negative 1, 0, 1, 1, 3, and 2, 5. And I can connect those. And notice that does form a straight line. So this is a linear function. Some characteristics of a linear function that might be of interest, well, this is not just of linear functions, but are the intercepts. So you may have an x-intercept, and or a y-intercept. So the x-intercept is where your graph crosses the x-axis. So in this example, this is the x-intercept, and the y-intercept is where you cross the y-axis. So in order to find the x-intercept, you can set y equal to 0 and solve. And to find the y-intercept, you'll do the opposites. Set x equal to 0 and solve. So in this example where I have f of x equals 2x plus 1, if I want to find the x-intercept, I'll say y equals 2, and then I'm going to set x equal to 0. So this would be 2 times 0, which is 0 plus 1, so y equals 1. That's the y-intercept. Now as far as an ordered pair, the x value there is 0 and the y value is 1. Because we set x equal to 0 and we found that y equals 1. Now to find the x-intercept, this says set y equals to 0. So I'll replace y with 0. Let's see, I'm trying to now solve for x. So I'm going to subtract 1 from both sides. So as far as my solution goes, I'll subtract 1 here and make a note that I'm subtracting 1. 0 minus 1 is negative 1. And 1 minus 1, those just become 0. So the last thing I want to do is divide through by 2. And I'll figure that x equals negative 1/2. So the negative that was with this negative 1, I'm just moving that to the front. This is like negative 1 divided by 2 is negative 1/2. So this is the x-coordinate, -1/2, and remember I set y equal to 0, so the y coordinate is definitely 0. Looking back at my graph, of course I was drawing this by hand, but it kind of makes sense. Look for the y-intercept, so this is where we intersect the y-axis. We should see that at the point 0, 1, and notice, there it is, at 0, 1 we're crossing the y-axis. And at -1/2 is where we're crossing the x-axis. So in this case, I did a pretty good job with my drawing. It matches up pretty well with the calculations there. All right, so another characteristic of a line that's often of interest to us is its slope. So the slope is sometimes defined as the change in y over the change in x. Other people like to say rise over run, but the formula that most people are familiar with uses the symbol m for slope and is y2 minus y1 over x2 minus x1. So in order to calculate slope using this formula, we need 2 points. So let me give you an example. Let's say we have the points 4, 2, and 3, 4. So it's arbitrary which of these we consider point number 1 and point number 2, but just because they're listed in this order, let's say that this is number 1 and this is number 2. So I'll consider this value to be x1, and this will be y1, and this will be x2, and this will be y2. So when I plug these into the formula, I'll have that the slope of the line that passes through these points equals y2, which is 4, minus y1, which is 2, over 3 minus 4. That's x2 minus x1. So simplifying, 4 minus 2 is 2, and 3 minus 4 is -1. So anything divided by 1 is itself, and if it's divided by -1, it'll be the negative of that. So this is just -2. Let's look at the graph of the line that goes through these points. So I'm going to draw another set of axes and make some marks here. So my original points were 4, 2. So 1, 2, 3, 4, and up 2, that'd be here. And 3, 4. 1, 2, 3, and up 1, 2, 3, 4. So this is the line that goes through the points 3, 4, and 4, 2. Now notice that this line has a slope of -2. What I wanted to point out is this line, as we go from left to right, this line falls, so it's going down, falls from left to right. And when we see a line that falls from left to right, we expect the slope to be negative. On the other hand, if you have a line that rises from left to right, we expect the slope to be positive. So I'll say m is greater than 0. The definition up here of slope included rise over run. I just want to point out that if we draw a path from this point 3, 4 over to the point 4, 2, and we only travel along horizontal and vertical lines, we can see that we move down 2, so I'm going to say -2, and then to the right by 1, and I'll call that +1. So this is the rise, and this is the run, and so using the rise over run definition, we can see that we end up with -2 over 1. I would just like to point out, you could go in the other direction from the point 4, 2 and travel back 1 and up 2. And in that case, we would have 2 over negative 1. I'm sorry, 2 over positive 2 over negative 1, which is still negative 2. So I'm going to pause the video or pause for just a minute, and I'll pick it up in our next video. Hope to see you there.